Hi, my name is Eric Chu, and I'm an industrial engineering major at Cal Poly San Luis Obispo. My presentation will cover Supplier A's background information and their current production scheduling problems. Then I will discuss the design alternatives I developed, testing of the designs, results, impacts of the project. Finally, I will discuss the industrial engineering tools that led me to my conclusions and my final recommendations to Supplier A. Supplier A was opened with the vision to provide the best products to its customers. Supplier A is in the aerospace industry. Supplier A's cycle time to manufacture products is very lengthy, and Supplier A also lacks a production system to accurately maintain WIP and inventory levels. The background of the project is that Supplier A is being contracted by Company X that requires Supplier A to be efficient. Right now, Supplier A's production system is not lean enough to fill current and future business needs of current Company X. The metric that I will be measuring Supplier A's performance is whether or not their deliveries to Company X is on time or not. I was part of Company X's team to ultimately audit Supplier A's supply chain and evaluate them as a supplier. The issue that I noticed with Supplier A is with their production control system. When supply chain analysts push work out to the floor, their ERP system does not place the prioritization of work orders, so the shop floor would be working on orders due months ahead instead of work orders due right now. Supplier A's goal is to have a minimum of 3 weeks of orders on the shop floor and a maximum of 5 weeks of orders at any given time, but their ERP system does not differentiate work order due date. This leads to an influx of WIP in Supplier A's production system that leads to lengthy cycle times from shop floor confusion. This process flow map is the assembly process of Supplier A's different products. On the bottom right corner, there is a legend describing the symbols. The green symbols show the Kaizen bursts and areas of improvement identified within Supplier A's process, and the letters depict Supplier A's different products that go through the assembly process. I was able to develop two solutions for Supplier A. The first design alternative is an Oracle ERP job scheduling module. I chose Oracle because Supplier A is familiar with it and Oracle and already utilizes it in its production system. All they would need to do is purchase and upgrade the job scheduling module available in Oracle's online system. I also conducted a line balancing analysis to improve the assembly process efficiency. I was able to do so by calculating the number of workstations required by taking the total work contact time divided by the cycle time. The results include adding 2 workstations for hand assembly and 3 workstations for soldering, which are both bottleneck areas identified in the previous process flow map. Oracle's ERP system would be able to have 4 different job scheduling techniques, which include critical ratio, earliest due date, first come first serve, and shortest processing time. The second design alternative is an Excel spreadsheet that I created. The spreadsheet has 3 main functions: the ability to enter in additional work orders with the necessary information, such as job number, due date, arrival date, and processing time. There is also a critical ratio calculator to display each work order's critical ratio. The color green means that it's on time, the color yellow means that it is currently on schedule, and the color red means that it's behind schedule and should alert the operator that the job needs to be placed on high priority and be run through the assembly process immediately. There is also a first come first serve calculator, earliest due date calculator, and shortest processing time calculator. Each of these are different job scheduling techniques that Supplier A could implement in releasing its work order to the production floor. The calculator will go through all the work orders and rank them, so then the operator can decide which method to proceed with. There is also the ability to import data, which is essentially a macro that copies and pastes all the current work orders into the different workstations. This is a user-friendly tool that the Supplier A will greatly appreciate. I learned firsthand how difficult it is in the aerospace industry to obtain any relevant data for this project. Due to proprietary and confidentiality reasons, the only data I was given was the processing times of the different workstations. The aerospace industry is a very highly competitive and very secretive industry. As a result, I had to use assumptions for the rest of the project, including cycle times, assume Company X was the only customer, and assumptions about the economic analysis. I test the alternatives by using a pro model simulation of the assembly process. While the Cal Poly curriculum teaches a different software, I used ProModel at a previous internship and prefer it because of its increased capability and user-friendly interface. The following is the results of the simulation with the different job scheduling techniques. Since the problem statement refers to the issue of whether or not supplier A was completing customer orders on time, I wanted my simulation results to refer back to this issue and reference on-time deliveries. The first come first served method is the most similar to the current process of supplier A because there is currently no prioritization of work orders on the shop floor. As a result, first come first served will rerun whatever is in front of them. The simulation results are clear. If supplier A utilizes the critical ratio while adding the appropriate number of workstations to eliminate the production bottlenecks, then their on-time deliveries will increase substantially. The critical ratio with the line balancing factor will follow the results of 90 yes on-time deliveries compared to only 10 late deliveries. This is a substantial increase to the first come first serve method, which is used to simulate the current process that supplier A has right now. When developing my design and finalizing my final recommendation, I had to consider any impacts it might have. The biggest impact it will have is on the employees of supplier A. The employees will need to be trained on how to use the Excel workbook and the additional Oracle ERP job scheduling module. According to my technical advisor, the Oracle ERP system is very not user-friendly and will take time to learn. Another additional impact is the transition from a paper system with printed work orders to an electronic system. This will greatly help reduce the confusion on the shop floor, as currently there are paperwork of work orders going back months and even years. So the reduction of paper will greatly reduce the shop floor confusion of the workers. I use many industrial engineering tools to come to my final recommendation. I use my simulation skills as well as many of the process improvement tools such as production planning, economics, and flowchart analysis. This project was a good accumulation of all the skills that I learned here at my time here at Cal Poly. My final recommendation will include the use of the Excel workbook for 1 year to allocate time for the planning of the construction of the additional workstations. Currently, the Excel workbook has the capability of calculating critical ratio as well as importing data to the different workstations. The Excel workbook also has the capability of a ranking system in terms of earliest due date, first come first serve, and shortest processing time. Moving forward, supplier A could transition to the Oracle ERP system so that they could align their systems together after the completion of their additional workstations. Currently, supplier A uses Oracle to receive and enter work orders. After they implement the Oracle job scheduling module, then it would be the best and ideal situation for them to have one system of Oracle instead of the Excel workbook that I created for them. This will create a uniform system which would create continuity and ultimately reduce confusion on the shop floor. Thank you.